We are Group 1. My friends Arun and Ishan have built a smart game. Let's get started. In this project, we are developing an assistant device for people with impaired vision. This project will help them navigate their surroundings and detect objects using a smart cane which will be detecting objects within a radius of 5 to 7 meters. To implement this, sensors will be integrated to an FPGA board to detect any obstacles in their surrounding, and these details will be relayed back to the user. Now, why use an FPGA board? Boards hold major advantage in terms of real-time processing power and true parallelism. In devices where there is a need to relay, process data gathered from various sensors back to the user in real time, FPGAs perform better than microcontrollers. Over to Ishan.
Okay, coming to the overview part. So upon doing some research on the topic, we were able to understand the utility of a range of assistance systems for general aid available to the blind. This graphic is basically a compilation of what all systems we came across so far. Starting from the very basic or fundamental form of aid available to them was assistance from a trained pet, a white cane, help from a friend or a family member, and ultimately the smart assistance systems that we are interested in. Now, these microcontroller or FPGA based assistance systems came in different packages or different types. Some devices needed the user to wear them, while some were simple handheld devices, and some devices were an absolutely separate entity. Most of the devices had maximum features and components in common, but had their own advantages and disadvantages. Now, out of the said options, we are planning to develop a smart assistance system around the cane, as discussed by Omkar. In the design of any product, be it a spoon or a vehicle, the comfort and choice of the user should be considered, and there are some points that we will be considering while designing, which brings me to my next slide. Okay, so some of the points that we will be considering are that users do not like feedback about presence of obstacles in the form of tactile vibrations in head. Users prefer devices which are only one hand in use, where only one hand is used. Devices which are not flexible in gripping styles or may require the users to adopt a new gripping style may not work. The ease of learning, the ease of usage, portability, appearance must be considered while designing the device. The users prefer devices which are small in size, compact, and weigh less. Often, most do not prefer rigorous scanning to detect obstacles. Over to Arun.
Uh, okay, sensor. Sensors are electronic device used to measure physical quantities. The main feature one should look for the sensor is are the accuracy, resolution, range, its interface, calibration, environmental effect, and cost. There are many types of sensor used to measure the same parameter. So for our project, we search sensors like ultrasonic sensor, IR sensor, and laser sensor to measure the distance, and stereo vision and RGBD sensor to gather the 3D data of the obstacle. The ultrasonic sensor uses frequency wave of around 40 kilohertz, whereas and laser sensor uses light to measure the distance. We can use stereo camera to gather 3D data, but it gives a black and white image of the object. And whereas the RGBD sensor gives the colorful image of the object and also uses the infrared sensor to get the more depth of the object. Algorithms such as Kazi algorithm, pyramid filtering, polygon segmentation, watershed segmentation can be used to remove the unnecessary data from the image which were taken by the cameras. And for the feedback, we can use vibrator or audio speech device to guide through the obstacle. So this concludes our project. Thank you.